In this video, I'll use the same code from the last video, and I'll finish up with the last few methods I want to cover on the collections class. Like the arrays class that gave us a binary search method for arrays, the collections class supports a binary search method for lists. Both methods require the elements to be sorted first, and neither guarantees what index is returned if you've got duplicates. The binary search method on collections is overloaded, like the sort method. I can pass a list of comparable elements, or I can pass a list with a separate comparator which will match the way the elements are sorted. Both methods take an element which is the element that will be searched for, which should be the same type as the elements in the list being searched. I'll use this method on my deck of cards next. First, I want to create a 10 of hearts card, which will be the card I want to search for in my deck. I'll set up a 10 of hearts variable and assign it what I get from the static method card.getNumericCard with hearts as the suit and the face value of 10. Now, I want a local int variable, which I'll call foundIndex, and I'll assign that the result of calling binary search on the collections class. I'm going to pass my deck a list and this new 10 of hearts. Lastly, I'll pass the sorting algorithm I set up earlier in this method that I used to sort with called sorting algorithm. I'll print the foundIndex as well as the matched element at that index position. Let's run the code to see if it works. And we have an error. As you can see, the index that came back was -53, not -1, but it still means the 10 of hearts wasn't found. Can you guess why? If you scroll up and review my code, you'll notice that on line 50, I reversed the original sort. Now I'm attempting to use binary search on a list that isn't sorted the way I specified. This is important. Your list must be sorted before you can execute a binary search on it. If I'm passing a comparator, my list has to be sorted that way before executing this method. I can fix this by calling sort again on my deck with the same comparator I passed to the binary search. I'll insert that statement before I create the 10 of hearts card. Deck.sort passing sorting algorithm. Rerunning my code now. I get a found index of 34, and sure enough it prints out the 10 of hearts element in the deck of cards, which is good since that's the card I was looking for, and confirms the binary search worked correctly. Remember, you can use lists index of method to do this same thing without the list being required to be in sorted order. The contains method on list uses the index of method to return its result as well. Let me show you that method for comparison. I'll add another println statement. I want to put this just before the last statement, and then call deck.index of, passing it the 10 of hearts variable. Let's see if it works. You can see that the found index is still 34 when using this method on the cards list, but now let's see what happens if I comment out that call to deck.sort before the binary search. Running this code now. You can see that the found index of the 10 of hearts is 17 in the second instance. The index of method on list can find the 10 of hearts in my list, sorted or not. The binary search gives us a result, but not one that is reliable, and that last statement again gives me an exception when I try to retrieve an element with that index. I'll revert that last change where I commented out the sort, so this code compiles and runs again. You might be asking, which method should you use? The basic rule of thumb is if your lists contain a small number of elements, or if your list is unsorted or may contain duplicates, then using the index of method or its cohort, the last index of method, will provide better performance. If your list is already sorted and contains a large number of elements, then the binary search method will likely produce performance improvements. Moving on, I want to examine just a couple more methods on the collections class. First, this class has a replace all method, like the list interface. Remember that the replace all method on list allowed us to write a function, a lambda expression, to do a global replacement of all elements. The method on this collections class is much more limited because it requires you to replace one or more instances with another. I'll use the collections replace all method to replace the 10 of clubs with a 10 of hearts in my deck. First, I'll create a 10 of clubs card using the static method card.getNumericCard, passing it the club suit and 10. Here I'll call replace all on the collections class, passing it my deck and first the 10 of clubs card, then the 10 of hearts card. I'll use the printDeck method just to print the 10s row sublist. My 10s row is now lower in the list since I resorted it, so I'm using elements 32 through 36 just to print out the 10s in the list. The output shows that I now have two tens of hearts, so replace all worked. This method will replace more than one element if it finds multiple matches. I'll copy those last two statements and paste a copy below, leaving an extra line. This time, I want the 10 of hearts as the first argument and the 10 of clubs as the second argument, because we are doing this in reverse now, replacing any 10 of hearts with a 10 of clubs. Time to run this to check if it works. You can see it replaced both 10 of hearts with the 10 of clubs. IntelliJ wants our attention on both of those replace all methods, and it's indicating that the result of the method is ignored. That's because this method returns a Boolean value, true if one or more elements was replaced, or false if not. I'll add one more call to this method, duplicating the call previously, but wrapping it in an if statement. If replace all returns true, I'll print that cards were replaced. Otherwise, I'll print a confirmation that no matches were found. Running this code now. You can see my output. No tens of hearts found in the list. That's because I replaced them all in the replace all call just previous to this call with tens of clubs. I'll leave those other warnings from IntelliJ. You should continue to pay attention to any warnings you see, since IntelliJ has had a lot more time to learn the rules than you have. I will sometimes purposely ignore these warnings as I am showing you the ropes, but let me encourage you to trust and use IntelliJ's suggestions while you're learning on your own. Another interesting function is the frequency method, which allows you to check for duplicates in your collection. I'll make a call to this method directly in a println statement. I'll pass it my deck and the 10 of clubs card. Running this. You can see the message showing that two tens of clubs were found in my list. Collections also give us both min and max methods, which take a collection and return the minimum or maximum element in that collection respectively, based on the natural ordering of the elements or a provided comparator. Like sort and binary search, you can use one of the two overloaded versions, the first if your class implements comparable, which I'm purposely not doing for card. The second takes a comparator, and that's the one I'll use here, passing my sorting algorithm variable to each of these methods. I'll call both from a println statement, first collections.max passing deck and sorting algorithm, and now collections.min with the same arguments. When I run that, it correctly identifies the best card as the ace of spades and the worst card as a two of clubs. Finally, let's look at the rotate method. First, I want to sort my deck by suit and then rank as it was in the beginning. I could just make another call to get standard deck, but instead, I'll just create a new comparator and call sort on deck and then print that out. Running that code to check the result. And as you can see, my deck is again sorted by suits and then rank. I'll set up an example of using the rotate method. First, I want a copy of the first suit in my deck. I'll create a new list variable called copied, and that will be a new array list. I'll pass a call to deck.sublist from 0 to 13 to the array list constructor, so this should create a list of just my clubs cards. The rotate method is a lot easier to understand if we look at the results while discussing it. Call collections.rotate, passing it my new list and the number 2. Print the unrotated sublist from my deck, and now the rotated copied list. Let's run and see what this produces. You can see that the last two elements in the original list, my queen and king of clubs, were moved to be the first two elements in the following rotated list. A positive number passed to this method moves that number of elements in the list from the back of the list to the front of the list, as you can see here. Notice that the order of the elements that were rotated is maintained, so Q is still before K in the rotated list. Now I'll try a negative number. I'll copy those last four statements and paste them directly below. I'll remove the type, list with card there, in front of copied to avoid redeclaring. Then I'll change 2 to -2 on the second and fourth lines. Running this code now. I want you to compare the output from the two different calls to rotate. In the first instance, the last two elements were moved to the start of the list, so the king and ace of clubs were moved to the start of the list. Using a negative number though, you can see it moves the elements from the start to the end of the list. Here, the 2 and 3 of clubs were rotated to the end of the list. Like shuffle and reverse, it's good to know these methods exist, so you don't have to spend time writing your own code to do these things. I said rotate was the last method I wanted to cover, but actually there is one more. I want to cover the swap method. Remember one of the previous challenges had you swap characters in a character array, reversing the characters in a string. With this method, I'll show you how to use the swap method on the collections class to do something similar. I'll reverse the order of my suit of cards. I'll start by making a copy of my first 13 cards, the club cards in the deck. Hopefully, you'll remember that when swapping elements to do a full reverse, you only need to swap half the elements. My for loop is from 0 to copied.size divided by 2. Call collections.swap, passing the copied list and which 2 elements should be swapped, ending with printing out the copied array. Let's see what those calls to the swap method did. You can see we successfully reversed the sublist elements. By the way, I could have simply done this by using the reverse method on this sublist. Let me do that for completeness. First, I'll copy and paste the array list again. Call collections.reverse, passing my copied list, and print that out. And as you can see, that does the same thing. Having access to the swap method allows you to have a lot more granularity in the ways you might use it. For example, you're not limited to doing a full reversal like you are with a call to collections.reverse. Okay, so those are a lot of the methods on collections, some of which you might find some use for, and it's good to know they exist if you might need this kind of functionality. Others are better replaced by lists' default methods under many, perhaps most circumstances. This class also contains a lot of methods for transforming collections into other collection types such as viewable, immutable, checkable, and empty collections, which I'm not going to review here. Many of these have been replaced with additional implementations in the collections frameworks, and I'll be covering these in sections where they're more relevant. In the next video, I have a collections class challenge. That should be fun if you like to play cards, so I'll see you in that video.